As we get started here, I will mention to you that I'm assuming that you've looked through my lectures about the introduction to sine and cosine function graphs, the amplitude of sine and cosine function graphs, and the period of sine and cosine function graphs. This isn't to go through that again. This is more or less as some sample types of problems. So the first type of problems that will be asked is to determine the magnitude and the period of particular functions without graphing, just being able to determine the magnitude and the period, the amplitude and the period, much like what follows. Okay, so we're to determine the amplitude and period of the following, and the first one is the graph of y equal -5 times cosine of 7x. And remember, in my discussions, this is A, and actually in the book, this is A. In my discussions, this coefficient 7 is B, but in the book, I think it's omega, okay, just as a point there. But regardless, we can do the problem in either case. So amplitude, if you recall, is given by the absolute value of A, and in this case, that's the absolute value of -5, since A is -5, and so the amplitude is the number 5. Very simple. The period, in terms of the sine and cosine function, the period is given by, we take the original period, that is the period of sine and cosine without any adjustments, that's 2 pi, and we divide it by B or omega, and in this case, that omega or that B is 7. And so it's the period here is simply 2 pi over 7. Very straightforward. That might be difficult to graph, but it's very straightforward. Well, here our function is y is equal to 2 sine of 4/3 times x. And so in this case, of course, our A value is 2, and our omega value or B value is 4/3. So again, it's very straightforward. Our amplitude is the absolute value of A. In this case, A is 2, and so the amplitude is 2. We could have looked at that and answered that question. I'm not meaning to offend you at all. Our period, okay, our period is 2 pi divided by omega. And in this case, omega is 4/3. So we have 2 pi divided by the fraction 4/3. So that's 2 pi times the reciprocal of 4/3, which is 3/4. And when we reduce this, of course, we'd actually get 6 pi over 4, wouldn't we? Which will reduce to 3 pi over 2. So we just have to be careful that we incorporate all the appropriate algebra. So here the period is 3 pi over 2. Okay. Well, in this case, our function, as you see, is y is equal to 2/3 times the sine of pi x. This is going to change things. We might be a little bit surprised here. It's not that big a deal. Our A is 2/3, but our omega is pi, isn't it? So when we calculate, I think I may need some room, so I'm going to come here. When we calculate our amplitude, it's the absolute value of A being 2/3. It's just 2/3, isn't it? So it wasn't a big deal, and that's, you're getting real quickly, I'm sure. Now, on the other hand, though, our period, remember, we take the original 2 pi and we divide it by omega. And in this case, omega is in fact pi, isn't it? So we take 2 pi and divide by pi, and we get 2. So our period this time doesn't have anything to do with pi after we do this division. Our period is 2 units long. So we go through a whole cycle in 2 units. Okay, let's do one more. Well, our new function is y equal -4/7 times cosine of 2 pi over 3x. So amplitude is very straightforward. We can look at it and tell, can't we? The amplitude is 4/7. It's the absolute value of A, and in this case, A is negative 4/7. So the amplitude is a positive 4/7. Amplitude is always a positive number. Now the period, again, is pretty straightforward. The period is 2 pi divided by omega. In this case, omega is a fraction that is 2 pi over 3. And so we have to do a little bit of work here with 2 pi. I guess the 2 pi we have here is like over 1, and we're multiplying by the reciprocal of our divisor, which is 3 over 2 pi. And so we see these 2 pi's cancel, and we get our period as 3 in this case. Let's move now to the next page to discuss how we would go about setting up to graph some particular functions. And like I said, we'll do that on the next page. Okay, here we're asked to sketch the graph of y equal negative 3 sine 2x. And before I actually worry about sketching, I'm going to kind of decide what the important features are. And so I certainly decide that the amplitude, okay, is the absolute value of negative 3, which is 3. So I know it goes as high as 3 and as low as negative 3. And the next thing I'm worried about is the period. And I know the period is 2 pi divided by omega. And in this case, the omega is this 2, isn't it? And of course, this negative 3 was the A. So 2 pi divided by omega, or 2 pi divided by 2, which is pi. Okay, sorry for that interruption. Now that means that my quarter points are going to be different, because I'm not going from 0 to 2 pi any longer. And see, it's kind of like I did before. You know, what's the home interval? So what's the home interval? That is, what's the cycle I'm worried about most? The interval of the cycle. And usually I'm interested between 0 and 2 pi, but now I'm not taking the sine of x, I'm taking the sine of 2x. And so I want my 2x to go from 0 to 2 pi. And so I would divide through by 2. I'm dividing through by this 2 in front of the x, so I find out what that causes for x. And of course, that gives me 0 is less than x is less than pi. And of course, okay, that's our home interval. So that means when we start to graph this, it's just kind of the idea. When we start to graph this, then we're going to start, this is the x-axis, of course this is the y-axis. And we know we're going to go up as high as 3 and as low as negative 3, okay? But what about our x's? Well, we want x to be 0, and we're kind of using the cycle of, oh, we're going to go out to pi, but we've got to break that into quarters. So I take half of that, that's pi over 2. And if I take half of that again, that's pi over 4. And so this position I need to figure out, and that's halfway between pi over 2 and pi, which happens to be 3 pi over 2. So those are the, now actually from that information I can get a quick sketch already. And maybe I ought to do that down here. Okay, here's the way I would approach this. Let's see, let's suppose this is where positive 3 is. And so this would be 2, 1, 0, negative 1, negative 2, negative 3. Okay, so here's my x-axis, here's my y-axis. And I'm just jumping out here and say, okay, here's pi. And as I'm scaling this, and I say, okay, I'm going to make this pi over 2. And so halfway here would be pi over 4. and halfway here would be 3 pi over 2. Now those are important x values, and that's what we were talking about earlier. Those are important x values. And you saw the reason those were important in the earlier discussions, video discussions, that I'm assuming you've already looked at. Now here's the issue though. Because our amplitude is negative, I mean not our amplitude is negative 3, but we have this negative in front of sine x, then that means that, usually sine x, well, here's what's going to happen. I guess I ought to do a little better than this. Okay. So we're going to use these x values. We're going to use x to be 0. We're going to use x to be pi over 4. We're going to use x to be pi over 2. We're going to use x to be 3 pi over 2. And we're going to use x to be pi. Okay. Let me show you how I'm building this up. Okay, so here's what I'm going to do in this first row. Actually, we're going to take the sine of 2x. So this is x up here. See, we've got y is equal to negative 3 times sine of 2x. And so what I need to know is the value of 2x. So let's go in here and figure out what 2x is. Well, if x is 0, 2x is 0. If x is pi over 4, 2 times pi over 4 is pi over 2. If x is pi over 2, then 2 times pi over 2 is pi. If x is 3 pi over 2, then, excuse me, I goofed up. This is 3 pi over 4 up here. My bad. This is 3 pi over 4. If x is 3 pi over 4, then 2 times 3 pi over 4 is 3 pi over 2. And if x is pi, then 2 times pi is 2 pi. See, those are the things that we want to take the sine of. That's the reason we chose those x's. Okay, well now remember our y. Well, let's do this. What's the sine then of 2x? Well, when x is 0, 2x is 0, the sine of 0 is 0. Sine of pi over 2, see when x is pi over 4, we're taking the sine of 2x, and the sine of pi 2x, which is pi over 2, is 1. The sine of pi is 0, the sine of 3 pi over 2 is negative 1, and the sine of 2 pi is 0. Now, here's the next deal though. This is the important part. Our y is negative 3 times the sine of 2x. So our y is negative 3 times this value, which is 0. Our y is negative 3 times this value, which is negative 3. Our y is negative 3 times this value, which is 0. Negative 3 times this value, which is positive 3. And negative 3 times this value, which is 0. So for this x, we have this y. For this x, we have this y. Now let's come back up here. So when x is 0, y is 0. That's this point. When x is pi over 4, then we look at our chart, y is negative 3, so instead of going to a high position, we went to a low position because of that negative in front of the sine x, okay? Then when x is pi over 2, our y value is 0, so we're back to this point. And we're expecting to go to a high position now. When x is 3 pi over 4, then our y is 3. And so here's 3 pi over 4. Our y is up here at 3. Okay? So going here, 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 here. And now finally, when x is pi, our y value is 0. And so we're back to this position. So we can sketch our graph, at least one cycle of it, very quickly now. And then, of course, it's going to continue, isn't it, in each direction, and we'd have to figure out a little bit more. But it was knowing these x values that is the critical part, and how high and low it's going to go, and which direction because of that negative. So that wasn't too bad, was it? As you can read here, we're to sketch the graph of y equal 1/2 cosine of pi over 2 times x. And as I did before, I'm going to collect some information, and we can tell real quickly here that the amplitude is 2. excuse me, is 1/2. So this doesn't go very high or low. And the period, we'll calculate real quickly. And the period is 2 pi divided by omega, and in this case, omega is pi over 2. So it's 2 pi times 2 over pi. And we see that ends up actually being 4, doesn't it? So the period is 4. Now, another way we could have looked at this, kind of like as we thought before, another way we could look at this is that we need our argument, which is pi over 2 times x, to be between 0 and 2 pi. See, we're taking the sine of pi over 2 times x, and what we really want are x's, so that we're taking the sine of 0 through 2 pi. And so in this case, I would multiply through by, I need to get x alone, so I multiply by the reciprocal of that pi over 2. So I multiply through by 2 over pi. And as I do, then you see, of course, we have 0 here. And in this case, we just have x. And in this case, as before, we end up having a 4. So this is really our home interval, if you will. That's what I call it, our home interval. And now, the idea, once again, is when we start to graph this, and we'll be a little more careful down here, but when we start to graph this, we're going to go up, our amplitude is 1/2, so we'll go up as high as 1/2 and as low as negative 1/2. And our period is 4. So, and it doesn't have anything to do with pi, does it? Our period is 4, and so we need to break that into 4 equal parts. So here's 2, here's 1, and here's 3. And in fact, we ought to be able to get a pretty quick sketch of this, actually, and I guess I can do that right here, because the cosine function actually starts up at a high position, doesn't it? And we don't have a reason for it to be down below, because we don't have a negative in front of the cosine. So cosine usually starts at a high position, and this is as high as it gets, is at that 1/2. And then a quarter of the way through, it comes and hits an intercept. And then halfway through, it comes and hits a low point, and then it goes back and hits an intercept, and then it goes back and hits a high point. And so we can sketch this graph pretty quickly. Say, there's what it's going to look like. And we've done that very simply because we know where those quarter points are and how things are going to work. So it gets easier and easier as we go through the experiences. Next, we want to come up with the equation for the graph that we see. Okay, for the graph that we see. So let me draw a graph here. Well, I've kind of emphasized some points here, but we're defining the equation of the graph that we see. Now, probably we should assume the equation is going to be of the form y is equal to a times the sine of omega x, or y is equal to a times the cosine of omega x, or bx, as I've called it before. So we have to decide which of those we think is most likely to look like, and because we start at an intercept, it looks like this is the model we're looking for. Okay, and so what we need to do is figure out what a is and figure out what omega is, and if we do that, then we'll have the correct function. And we can see real clearly here that a, we can look and see the amplitude. See, here's the amplitude, isn't it? And it's 3. That's 3 units. And so we know a is 3. Now the omega is a little bit more of a difficulty. Here's what we know, is that the period we calculate by saying 2 pi divided by omega. And in this case, we can look at the graph and tell the period is actually 2 pi, can't we? I mean, excuse me, 2. See, if we go through a period from 0 to 2, so we can tell the period itself is 2. So we've got a little equation that we can solve for omega, because we know the period, 2 pi over omega, is in fact 2. We'll multiply both sides by omega, We're solving for omega. So we'll multiply on both sides by omega. And of course over here we end up with 2 pi. And over here we end up with 2 omega. And then we'll divide on both sides by 2. And that will give us that omega is equal to pi, won't it? So now that we know what the amplitude is and we know what omega is, then we just need to put those two pieces together and say, oh, okay, then this is the graph of y is equal to a, which is 3, times the sine of omega, which is pi x. There's the graph of that function. Okay, let's do one more on the next page. Well, that's not a real beautiful graph. I apologize for that. But here's the graph we want to write the equation for. And we're kind of in the same position as we've got to decide, is this based on a sine function or a cosine function? Okay, that's the first thing we have to decide. Now, a sine function starts in an intercept, doesn't it? And a cosine function normally starts up high, but it can start out low, can't it? So start at the intercept at 0, 0, and that's not what we have here at all. So I'm thinking it is this form. So once again, we have to decide what a is equal to, and okay, that's what the two pieces we have to make a decision on, and then we'll have our model or our equation. Now, here's what we do know is that the amplitude, which is the absolute value of a, is equal to 2. We can tell what the amplitude is, can't we? There's the amplitude, it's 2 units. But here's the problem. Normally, a cosine function starts up here like this. But ours starts down low. And so that means we have to have reversed that. See, how do we start low? By having a negative in front, don't we? So from that idea, we can conclude that actually the a is a negative 2. That's how we ended up starting low instead of high. Now, omega is the same kind of problem we had before. We know, on the one hand, by looking at the graph, that the period is pi. We can tell what the period is by looking at the graph. On the other hand, we know we calculate the period by taking 2 pi and dividing by omega. And so it's those two pieces of information that will allow us to decide what omega is. We have 2 pi over omega is equal to pi. So we'd multiply both sides by omega, and when we do, we'll get 2 pi is equal to pi times omega. And then when we divide through by pi, we'll have omega is 2 pi over pi, or omega itself is 2. Now, this information and the fact that we decided it looks like this, we get y is equal to our a, which is negative 2, times the cosine of omega x, and omega is 2. So this is the graph of y equal negative 2 cosine of 2x. And now you could think backwards and say, yeah, that's what it would look like if I analyzed this. Well, I think these problems are good to get you started on your homework. It may not be all inclusive, but I think it gives you a very good start, so good luck to you.